Coasts are dynamic landforms shaped by wind and waves. Shorelines change over time as erosion draws sediment into the beach and while complex root systems help to stabilize the bank. This study aims to understand the dynamic nature of coastal landforms and what factors contribute to living shorelines. As opposed to the hard erosion barriers often found along the coast, living shorelines are composed of natural materials such as driftwood, vegetation, and rock, which help to stabilize the bank. We have chosen to focus our research project on Dennis Beach, which is located in the mega-tidal environment of the Bay of Fundy. Our work examines how Dennis Beach has changed over a period of approximately 80 years and seeks to uncover whether driftwood and soil deposition have contributed to the emergence of a living shoreline.
Dennis Beach is located on the southern coast of New Brunswick on the upper reaches of the Bay of Fundy, approximately 9 kilometers from Fundy National Park. This area is a mega-tidal environment with a tidal range of approximately 12 meters. Continental westerly winds are prevalent here. These, along with the moderating effect of the Atlantic Ocean, shape the climate in this area. The superficial geology of Dennis Beach is a combination of marine and glacial-fluvial sediments, as well as a late Triassic Fundy Group outcrop located at Redhead, which lies at the eastern end of Dennis Beach.
Our research question is, does the presence of driftwood and soil deposition from the previously eroding bank contribute to the formation of the living shoreline on Dennis Beach?
So we collected data between August 31st and September 1st, 2021. A tape measure was used to mark 100-meter reaches across 1.4 kilometers of Dennis Beach, resulting in 14 individual reaches. At the beginning of each reach, GPS coordinates were collected using the Physics Toolbox app. Photographs of the bank were taken at each reach to observe the transition of the living shoreline and to compare it to historical images of Dennis Beach. In the center of each reach, sediment samples were collected from the toe of the bank. These were placed in labeled baggies. Observations were made to determine vegetation cover, driftwood abundance, and the types of driftwood that were present in each reach. Using percentage values, vegetation cover was estimated and categorized based on how much of the bank was bare soil, grasses, herbaceous plants, shrubs, and trees. Driftwood abundance was recorded based on whether the reach had low, medium, high, or no driftwood, as well as whether the driftwood was natural, from a decaying wharf, or from construction. We also recorded the length and diameter of approximately 10 pieces of driftwood per reach. This was done using a large caliper and tape measure.
So in the lab, our soil samples were poured into buckets of water to separate the organic matter. And once it was separated, we dried the samples, weighed them, and then put them into a sieve stack where a machine was used to separate the grain size. A program called Gradistat was used to record the weights of each grain size and produce statistics. We also did image-to-map rectification using ArcGIS to overlay historical photos to a present-day map of Dennis Beach. Adobe Lightroom Classic was used to put together reach images and also enhance the historical photos. And we also used Google Earth to compare Dennis Beach to other coastal areas in the upper Bay of Fundy region.
So we saw a lot of variation in driftwood coverage. So when we were looking at driftwood, we looked at both the coastal environment at the foot of the bank as well as the terrestrial environment higher up on the slope. So at reaches 1 to 3, there were a lot of bare spots, there was a lot of erosion. We saw some trees coming down. There wasn't much vegetation. And then at around reach 4, it was kind of a transition zone. We started to see more driftwood. There was also some more vegetation. And then by reach 5, we could clearly see the living shoreline, which extended to reach 13. And throughout these reaches, there was also high driftwood. And then by reach 14, it was kind of tapering down a bit, and there was a little less vegetation, and there was less driftwood as well. Some of the main vegetation we saw included American dune grass, and then higher up on the bank we saw alders as well.
So yeah, we used Google Earth to observe patterns between Dennis Beach and other soft sediment bank coastal areas, and we mostly found that these areas had no driftwood, whereas Dennis Beach had driftwood, and the driftwood at the other beaches were minor, but they have not retained over time. And then when comparing Dennis Beach to coastal areas that had driftwood, we found that most of these areas were low topography and the beach types were variable.
So for this study, we had aerial photos of Dennis Beach going all the way back to 1939. Looking at those 1939 photos, what we see is very patchy vegetation along the entire length of the slope. Moving forward to 1963 and right through to 1984, what we see is that the vegetation was actually increasing and kind of dispersing across the entire length of the slope area. We also see in 1984 the first evidence of a living shoreline appearing, a very small patch near the western end of the beach. However, in 1996 to 97, we see a huge change with vegetation covering nearly the entire slope, plus a strip of living shoreline running the entire length of Dennis Beach. Comparing that to current photos, what we see is that a small section of the living shoreline has actually retreated on the western end, but has remained in place along the rest of the beach.
So the only independent variable that we could confidently say showed variability in our study site was the superficial geology. And this was also reflected in the sediment samples that we found, which were mostly poorly sorted. Now, as for the driftwood, we think that it's distributed on the beach the way it is due to the currents, as well as the southwest and westerly winds. And we think that the vegetation is also growing there, which helps stabilize the bank.
So yeah, as said before, we compared Dennis Beach to other areas around the upper Bay of Fundy, and this was to gain a better understanding of the emergence of the living shoreline. And from these observations, it was seen that Dennis Beach is unique, as it has both driftwood deposits and a soft sediment bank. And the other areas compared either had a soft sediment bank with no driftwood present or driftwood deposits with a low topography area. So based on these comparisons, it's evident that the combination of driftwood and soil deposition from the eroded bank played a role in the formation of the living shoreline on Dennis Beach.
Going forward, if we could continue with this study, I think that more advanced comparative investigation would be good, like comparing other beaches to Dennis Beach. Some of the beaches that we discussed a little bit in our results were Mary's Point, Long Beach, Point Wolf Beach, and Martin Head. So looking at those more in depth in a comparative manner might be helpful. And then just having a better understanding of all the variables that come into play with contributing to living shorelines. Knowing that could be a really important asset in beach restoration and erosion prevention.
So in our study, we found that many factors actually contribute to the emergence of a living shoreline, including driftwood and soil deposition. And judging by our historic aerial photographs, we were also able to see that the living shoreline has experienced periods of growth and regression over the past 82 years. And so I would say that the key takeaway here is that we need to give living shorelines room to move through these natural cycles of growth and erosion.